part E.4. Hints for homework 1, part 4. Last two questions. Number 20 and number 24. Yeah. All right, so first, question number 20. Given a 185 element array, what is the minimum number of comparisons that we need to find an element that is among top 5 in the sense of values? So if we sort this array in increasing order based on the values, then we want to find one of the elements with the highest among the highest top 5 values. That's the meaning. Okay? Yeah. But here we cannot sort because in that case we need to use too many comparisons. Here we just want to use the minimum number of comparisons. So this question, so it is a good exercise question for that elimination method. So here, let us use the elimination method. We try to eliminate those elements that cannot among the top 5, right? Yeah. If we can eliminate those elements that cannot be among top 5. Yeah. All right, so first, the idea. Yeah, we talk about idea. So eliminate those elements that cannot be among the top 5. All right. Yeah. Although we understand this strategy easily, but how to implement, right? So here, the strategy is, the question is how to implement. How to implement the strategy. That's the question. Okay. All right, so to implement it, yeah. All right, so here, yeah. Think about this. All right, so yeah. All right, so here, another, we need to go. Yeah, although this idea, but yeah, because this idea, the implementation may not be very easy, right? Yeah. So in order to get it relatively easy, so we change to, we just want to select one element that is among top 5. Yeah. We just want to select one element that is among top 5. All right? Yeah. So that's the, from the original question. But you can see this is easier than the first sentence. Easier. Yeah. We just want to select one that is among top 5. Okay? All right. So then, how do you know some element is among top 5? Okay? Yeah. How to describe it? The question is how to describe it. Right? How to describe it? How do you describe an element that is among top 5? Yeah. Here, let me draw a diagram. 185 elements. All right. Top 5. Suppose we sort in order top 5. Remaining 180. All right. Now we want to get one that is among top 5. What property does it have? Property. What property an element among top 5 should have? So that property. Here, let me write that property. It is greater than at least 180 elements. Right? Yeah. It is greater than at least 180 elements. That's the property, right? Any element that has this property, it is greater than at least 100 elements. Then it must be among top 5. Is this simpler? So if you look at it in this way, is this simpler than before? All right, so based on this property, now our new idea, okay? New idea. Yeah, because this old idea hard to implement, right? Yeah. Pretty hard to implement. Yeah. Okay, so the new idea, okay? New idea. Can you find an element that can beat 180 elements? Yeah. Basically, we translate the property, right? Can you find an element that can beat 180 elements? If you can do it, if you find a way to do it, then you find an element among top 5. Think about that. Think about that. Using the minimum number of comparisons. All right? Yeah. Okay. Yeah. So that's the hint for this question. That's the hint. Okay. All right. Yeah. Next question. Given 2 ordered arrays, 3-element arrays, A1 less than A2 less than A3, the first one, B1 less than B2 less than B3. We want to find the median of these 6 elements. So we have total 6 elements. All right. What is the median of the 6-element array? So if we sort them in ascending order, then the third one we call the left median, okay? Not the right median, not the fourth one. Third one, yeah, so this is the median. All right. Yeah. Now we do first comparison. A2 and B2, we do first comparison. And we know A2 is less than B2. So now the question, what are those elements that can be eliminated from consideration as medians? Yeah. Based on the given information, what are those elements that cannot be considered as the median? So we should eliminate them. Then make the question simpler. Yeah, so this is another good question for elimination method. Yeah. All right, so here, in order to solve this problem, hint. Okay, yeah. First, simple fact. The median is although it is third smallest, but it is the fourth largest element, right? It is the fourth largest element if we look at from the right. Count from right, from left, two directions. Yeah. So based on these simple observations, now we try to set some rules for elimination. Yeah. We need to set rules for elimination. Okay, all right, yeah. When we do elimination, we use these rules. All right, the first one. All right, those elements greater than at least 3 elements should be eliminated, right? Yeah, so here, because for elimination, so those elements greater than at least 3 elements, okay? Yeah, greater than 3 elements, so this part, at least 3 elements should be eliminated. So if you can determine some elements that are greater than at least 3 elements, they should be eliminated. The first rule. The second one, those elements smaller than at least 4 elements should be eliminated, right? Yeah. So those elements smaller than at least 4 elements should be eliminated. How about that? Yeah. I noticed, some of the students working on this problem before, they just select one of the 2 rules. Yeah. So they observed either the rule number 1 or rule number 2, but not both. Okay? Then they didn't eliminate the maximum number of possible elements. Yeah. Here, you need to, using these both rules, eliminate elements from both sides, not just from one side, from 2 sides. then you can eliminate as many elements as possible. All right, so that's the question number 24. And I complete all the hints for homework assignment number 1. All right, so I've